First, a confession. I don't think I ever found a bug by using a real debugger. By now, I've probably found and fixed hundreds of bugs, mostly by reading the code and printing values to the console, like a caveman. Years of experience using JVM, and the same for the JavaScript. So I had access to all the wonderful toolings that this platform provides. And yet, this is not my cup of tea. If you find adding markers, stepping into or over the functions useful, you do you. But if you wonder how to debug Haskell programs without a real debugger, this tutorial is for you. Especially if somebody convinced you that Haskell is pure, so you cannot print anything. Note that everything we talk about applies to PureScript as well. Here's a simple program we are going to debug. First, we fetch some raw data, which is hard-coded and boring for now, but use your imagination. Then we decode this data as some sort of items from the JSON. Then we process it by filtering stuff out and mapping it to what we care about. And at the end, we report the result. The reporting just takes a list of results and prints them out. Nothing interesting. We'll reinvestigate a genuine bug I made while trying to create an example for this tutorial. I mocked some data, provided basic implementations, which not very exciting. I expected that when I run this program, it would print at least one result back, but surprisingly and luckily, I got an empty result, so I messed up. Before it's a debugging time, and just a reminder, there is no global state we have to worry about in Haskell. Functions depend on their inputs and nothing else. So it means I messed up somewhere inside a function. The program takes no inputs, no parameters, specifically in one of these used functions. Because there are 4 steps, there are 4 major places for the bug to hide. So we can keep narrowing down the scope from here. Of course, there are more than just 4 places. You can always pass empty list everywhere, but the program is so small and the types are strong enough that it's hard to mess up otherwise. We can add a few prints to check which step fails or produces unexpected results. So let's see the output this time. When I first saw it, I thought, okay, step 1 looks okay. But then somewhere in the step 2, we lost all the data. Step 2 is about decoding items, so I thought, okay, let's zoom in and look at the decode items function. I was trying to cut the corners and defaulted to an empty list in case of any errors, because I obviously didn't expect any errors on the first try. So wouldn't it be nice to actually see these errors right now? Also note that the function does not return an IO. And I know, the first snippet was unfairly easy to debug, because we could just print with putStringLine things when we use IO. But we don't always have this luxury in Haskell. If we try to rewrite it and use some kind of fake do notation and try to naively print stuff, we get a compilation error. We cannot mix IO and not IO expressions like that. So what do we do? Well, in this simple case, we can change the type signature to IO of item, rewrite the function, add putStringLine, adopt callers to the new result type, find the bug, and eventually roll everything back, which works. But this is super annoying, especially if you have more than a few nested functions and not one-liners. This is where debug trace comes in. Debug trace is part of the base standard library and provides several functions for printing values. For instance, we can use trace showID to print the results of the decoding. When we run this, we see a new trace in the log, which says that we got a left with some JSON parsing error. So what exactly is this function? The function shows and returns the value, so we can seamlessly plug it in most cases, given that a value is showable. The only issue is that we are printing the value without any label or indication, which can easily be lost among all the other output. It would be nice if we could add some searchable tag or meaningful prefix like debug or help me or bunch of ones or exclamation points. The trace module provides other alternatives. We can use trace to make a custom message. This time we're not only showing the value we care about, but also a small tag. This time we acquire a searchable label, which is a bit easier to navigate and find in case we have a bunch of logs. But a little problem is that it requires moving some code around. In this case, we had to extract the stuff that we care about so we can afterwards print it and return it, which is a bit annoying. But if you're from the future or lucky enough to use the latest GHC, you can use trace with to get the best of both worlds. As you can see, I'm not there yet, but the idea is that you can get the result and then modify it for tracing to add some custom label or something, and then it's going to be returned as normal. Or in other words, if you're using PureScript, spy is the only function you need. It prints and returns the value, but also takes an additional label. This example is similar. We read some JSON, trace its value, but we also add a label. And it comes from the debug module, which comes from the PureScript debug library. As a bonus, spy has a custom usage warning, so we remember not to push this into production. When we run this, we see the label and the value. This example is even more simplified, so it just says that JSON is not valid. Doesn't matter. So where is the bug? Here is the full decoding error right next to the function. The bug actually didn't hide in the decode items. It received corrupted data from its input, the output of fetch data. I just didn't notice it. Because in the raw data, if we scroll to the end, we can see that it's a broken JSON. I left an extra curly bracket at the end. So we are trying to decode a list of items, but we can't. This time, after narrowing down the scope once or twice, it was easy to spot the bug by reviewing the code. It was also easy to run everything. What if it wasn't easy? What if we had a large application with more hoops to jump through? But again, we don't have to struggle debugging functions somewhere in the middle of the production application. Functions only depend on their inputs. We can find problematic arguments or inputs and test functions in isolation. If you want a simpler and faster feedback loop, you can use GHCI, an interactive environment, also called REPL. How to use it is out of the scope of this tutorial and depends on personal preferences, but the rough idea is this. Find the problematic function by running the whole app or specific functions using GHCI. Modify the code, for example, to add some prints and traces, find the problematic inputs, and repeat with a narrower scope. Pretty much what we did, but running less. Alternatively, if you like writing tests, you can follow a similar process we did with GHCI, but instead of reproducing a problem by running the function with problematic inputs in the GHCI, paste them into the unit or property-based test. As a bonus, you can keep this test to catch any regressions in the future. So for me, debugging in Haskell comes down to using prints and traces or proper production observability, actual logging and tracing to narrow down the scope of the bug and using tests or GHCI to reproduce and fix this issue. In the example, we started from program, found the problematic functions using prints, stepped into it, found an issue using tracing, and the rest is history. Tune in next time when I'm going to be tracing issues with the microphone and debugging the camera. So